Welcome to the Angularlicious podcast. This is a special edition of the Angularlicious podcast because it's a video presentation, and it will be talking about a schematics for a better workflow talk that I'm preparing for the Angular Summit in Clearwater, Florida in December 2018. So looking forward to that. In about 1 week from now, I will be there. And so looking forward to talking about schematics. So schematics, pretty cool stuff here. So let's get into the presentation. It's a schematics for a better workflow. And when we talk about workflow, it means a lot of different things. But first, let me introduce myself. I'm Matt Vaughn. I'm a developer, speaker, consultant, podcaster, Angularlicious podcast. Please check it out. Musician when I can get the band together. And I'm owned by a Siberian Husky. So if you'd like to stay in contact or ask me a question, my Twitter handle at Angularlicious, or you can go to my GitHub account, Angularlicious, to get all the source code, resources, everything for this talk and presentation. As mentioned, Luca the Husky, if you want to follow him on Instagram, it's Luca the Husky. He may not follow you back because he only follows animals. So unless you're an animal, probably won't happen. So talking about the resources again, the GitHub account basically has the sample Angular Workspace with schematic projects, the different schematics, the setup, how to build, test, debug, etc., all these different things. I've added some online links. I've created 3 guides, PDFs that you can download. They're on the GitHub in the guides section, how to basically add schematic projects to a workspace, how to configure options for schematics, and how to debug and test schematics and such. So there's a reference to a book by Manfred Steyer and some videos that I found very helpful in kind of learning kind of what schematics are about, what they do, what they're capable of, and such. So anyway, the resources are available on the slide deck, which you can get at the GitHub Angularlicious site. So question, what really matters? And at the end of the day, I think what really matters is value. What are we delivering to our customers? Are we solving the right problem? Is it a better experience? Is it efficient? Is it reducing cost? Is it improving performance? Is it making money? Increasing profit and revenue? Is it improving the life or making our end users happy? Does it have a benefit? And are you a happy developer? These are really important questions because our workflow really matters in what we do, and how we add value does matter. And I think it makes a big impact in our work lives and in what we do as software developers. So workflow does matter, and really what's going on in the state of workflow today is that many teams and companies and developers, they're really accelerating their workflow and delivery of their solutions, not just delivering a solution, but delivering high quality solutions the first time. And the reason why they're able to do that is because they're taking advantage of mature conventions, opinionated frameworks like Angular. They're using great tools like the mono repos, the workspaces that Angular is given. We have code generation and scaffolding tools. We have so many options out there in terms of different packages that we can pull into our projects that do things that we normally years ago would have to handcraft or write our own, but really these packages are just kind of off the shelf, ready to go. We got control suites like the Angular material packages, our tools for developing software, our IDEs, our text editors, our work environment, our continuous integration, continuous deployment, Docker containers. Everything is really moving at quite a pace. And we have processes are really moving at the same pace to really accelerated to basically deliver these solutions and such. And we also have different language capabilities that we didn't have before in JavaScript and TypeScript and such, being able to use object-oriented programming concepts like abstract abstract classes, interfaces, enums, using design patterns with TypeScript, things like that. So we have lots of capabilities now that we never had before. So if you're taking advantage of these things, then you're probably going to be successful. So we need to pay attention because it's pretty competitive out there. And if we're not effective as a developer, or our team is not effective and our company is not effective, we're not going to last. We're not going to be able to do the kind of work we want to do for as long as we want to do it. And that's just plain and simple. So what do we do? Where are we at right now? So we're going to talk about schematics and how they kind of fit into our workflow and our environment. But before we really get into schematics, though, I want to spend just a moment talking about code generators. Code generators have been around for a long time, and schematics are partially a code generator. It's one of the things that they do very well. So let's talk about code generation for a bit, but why generate code? Is it a good thing to do? When we think about why people and the motivation for creating these code generators is that a lot of times there may have been code that was difficult, error prone, complex, or even really boring code like boilerplate code that was so repetitive, but there's so much of it. You could actually create tools to automate the creation of that kind of code. And when you do that, it really basically allows for a better output because it's consistent and maintainable if you're using a specific recipe and template. So you take the human element out of it, and they don't have to like forget or miss a step or don't exactly do it correct in the correct order or sequence or follow the recipe exactly. And when that happens, you don't get the right output. You get this variance in output and such. But with code generation, you always get the same output from the input that you provide. So it's very consistent, it's very maintainable, it simplifies complex processes, and basically it allows you to really enforce standards, convention, compliance with different coding styles and conventions, patterns, and things like that. So code generation is a good thing. It's been around a lot for a long time, and there are many code generators out there, different purposes. Not a predecessor, but another one that's very common today is Yeoman. Does certain things, but we're going to look at schematics, and not that it's a code generator. It does that, but it does a lot more than that. So we're going to talk about that. But first, when we're thinking about code generation, in really this concept here is really important because it's going to affect how we build our schematics if we want to build custom ones. So the question is, how do we get to a point where code generation is possible? So you just can't generate anything. You have to have something that is generatable, if that's a word. And the reason today that many things are able to be generated is because it's the adoption and use and execution of good programming practices and principles. Things today are more consistent and reliable and even more conventional than ever before because we're using these established patterns and practices. They're kind of baked into the DNA of our frameworks that we use, the tools, the plugins, the languages, all of these things and these practices and processes are basically raising the quality and making our software more conventional and consistent. So we have things that can be generated that could not have been generated maybe years before, but now can because of all these different practices and principles and tools. So think about this question when you look at code in your environment, because when you're using schematics or building schematics, you want to basically automate something that's difficult, mundane, error prone, or big in process, and make sure that you can automate that using a defined, consistent, reliable, conventional template. So what do schematics give us? What are they all about? And do I really need them? It's a good question. So if we just take a high-level look at some of the capabilities of what a schematic is or what the schematics are, it's basically an engine that allows you to build things. But what do they help you to build? So when we think about projects, the Angular schematics enable us to scaffold new projects very quickly. It's just ng new, project name, maybe pass in scope. If we want routes, we pass in that. We can pass in other options. And in a few moments, we have a complete project with all the folders, files, configurations. We can just do ng serve, and bang, we got a web application running in a browser in just a few minutes. That's pretty cool. Versus go back in time a couple of years or more, and we're looking at Angular 2 beta. We didn't have the CLI up early on, or I don't remember it being available, and trying to figure out how to create a project, an Angular project. There are different teams and people putting these starter kits out on GitHub, and some are using System.js, some are using Webpack, some had different file and folder structures and different ways of doing things and such. And if you ask 10 developers to create an Angular project at that time, you were going to get 10 different ways. Well, with the Angular CLI, which is really using schematics, it basically makes or allows everyone who's creating an Angular project not to just focus on creating projects, configuration files and folders and all that, but actually focus on really building things of value, things that add value to our customers, things that improve performance and revenue and profit and make our customers happy. And so we can now scaffold these projects, and we can do that with schematics that allow for configurable options. So it's not kind of tying us into just one way of doing it. We have a very conventional way of establishing a project, but it's very configurable if we want to add different options to it. And not only that is it just creating a project for us, but we have schematics that help us to add things to our Angular projects, like modules, components, services, classes, pipes, directives, routing, state management, things like that. And other teams and developers are creating schematics to enhance our code formatting, like Prettier, for testing, like with Jest or Cypress, and routing. You can even have packages, schematics that do package updates. So going from one version to another version of Angular, or from Angular material, etc. So we have a way for these schematics to actually work with other schematics. They can execute internal and call external schematics, etc., etc. And so they're really doing a lot. And when we think of some of the packages out there, they're really kind of baking in schematics and this mechanism into their own packages. So Angular Material has schematics, Angular has schematics, NGRX does, Narwhal does, Akita has schematics for state management, and on and on and on. So it's becoming very, very popular, and it's going to be kind of almost in a short term, maybe a requirement for actually part of our workflow and creating things for our teams. So how do schematics work? Sounds like they do a lot of things, and we've been using them since the CLI version 1.4-ish. We've been using schematics when we do ng new or ng generate service or module component. We're using schematics. So really what we're doing is we're using a code generator of sorts. That's just one of the things it does. So it takes input and options. So we just say, hey, ng, a name of a schematic, and we add some options. This CLI passes that information to the schematic engine. And what it does is it processes a set of rules, template rules and filters and all these rules and such. So a rule calls another rule, that may call a rule, that calls another rule, et cetera, et cetera. So you have the kind of chain of rules, and each of these rules do different things, and they're processing our execution command to create a component. And the output really is a set of files and folders that took that input, and based on what templates were used during that process, it can add files, update files, or remove files during that process. So that's really unique when you think about code generators. They really just create things, but the schematics engine really does a lot more than that. It has the ability not only to add files and folders as an output to your command, but it can also look at existing files that are in the system. It could add them, modify signatures, add import statements, add items like components to a declaration in a module, and it can remove files that are no longer needed or necessary. So schematics do a lot more than just code generation. And the way they do it is really interesting because there are really no bad side effects, because when all those rules are processing, if one rule fails, then the whole operation fails, meaning nothing is committed to the physical file structure. So what happens is all virtual in a virtual tree, a virtual file system. And this virtual tree has other information and things in it that it's working on. Excuse me. And if all things go well, then the output of that is applied to the physical tree. But if something happens and goes wrong, then nothing is applied. So it's kind of like a database transaction. You begin a transaction, you do some inserts and updates. If everything's good, you commit the transaction. And another analogy would be almost like a GitHub repository. You create branches, feature branches, and such to do things virtually, kind of. And when you're in a state where it's good, you basically can merge those changes into your developer master branch. And that's really kind of what Schematics is doing. So when things are in a specific state, then what it's going to do is merge those changes back into the physical file structure. In fact, some of the commands are actually merge and branch or merge with, things like that. So anyway, if you kind of have those things in mind, that's really kind of what Schematics is doing, is just creating these new things, updating things, and removing things. So let's talk about getting started with schematics and how easy it is, really. So it is easy. It's not that hard. So what we're going to do is talk about our environment and our tools, what we're going to need to get started. And then we're going to build and use some options and kind of see how things work with templates and debugging and such. So the part one of this video series is really going to kind of be just setting up your schematic in your environment, getting it built and deployed, and then executing it so that you can see it work. And then the next parts will be options and debugging and live execution in different formats and such. So the first thing we need to do is we need to install some global packages here. Number one, we'll install that later when we're developing our custom schematics, because the schematics, Angular has a bunch of utility functions that make that a lot easier, and that's a new thing that's available, and we can install that later. But items on line 2 and 3, these are global packages that we want to install from the Angular DevKit, Schematics, and the Schematic CLI. Those two things. And then in the second block there, we want to install a couple of things from Narwhal. And this is to support working with schematics in a workspace. So we're going to install the Narwhal Schematics package and the Narwhal NX package, and you can install those globally. So make sure you have those installed. And once you do, then basically all we need to do then is basically get a environment ready. So what we want to do is I'm going to set up Visual Studio here. So let's do that. And what I should do is probably close this. Sorry, guys. I had a... All right. I want to make a new folder here. All right. We got learning schematics. All right. We're going to do learning schematics. We're going to do getting started here. So let's create a new workspace. And this is going to be kind of our environment for our where we want to put our schematic projects. Okay. So what we want to do is if we install the Narwhal stuff, it's pretty straightforward. We're just going to create NX workspace. give it a name, and the name that we want to give it is getting started with schematics. Pretty big name here, right? But it's important. Okay, that's our name, and we can give it an npm scope here. And let's, since we're in Clearwater, let's say our scope is Clearwater. npm scope equals Clearwater. Hit enter. Basically, we're using schematics here, so it's creating a sandbox. It's running all the different things we need, getting packages, creating files and folders. If everything works well, what it's going to do is it's going to apply the files and folders to this specific folder called Angular Summit Clearwater 2018. And we're going to have a folder called Getting Started with Schematics, right? One of the things, new things this CLI is doing is it has prompts. So we'll use npm, and looks like we're good here. We got our files are created, and right now what it's doing is probably doing an npm install, getting all the packages so that we're ready to go when we have this. So next thing we're going to do after this is we'll open the folder to this specific workspace, and then we're going to want to create a new schematic. All right. So one reason why we're while we're waiting here, one reason why we're using Workspace here is because as Angular developers since version 6, when we're using a workspace, we have the ability to create as many applications we want in a single workspace. So they can share the same libraries that we add to this workspace. So we can have many libraries that use other libraries that are shareable as well, but we have one set of them, and we don't have to copy code from one application to the other. So this is a good thing to do because we have a mono repo style, we have a unique, a shared version, and we have shared libraries, and all of our projects are basically are much more maintainable in that kind of environment. So we have a workflow where we can create these reusable, shareable libraries and take advantage of that. So the question is, where do we put our workspace or our schematic projects? So I think that we should be able to, since we already work in workspace environments, that schematics should naturally fall somewhere in a workspace. So let's go ahead and open our workspace folder. So it's getting started with schematics. I'll select that folder and do a quick reload here. And basically what we have is a workspace with no apps, no libs, nothing. And the first thing we want to do is basically let's create a folder for our schematics. So I'm just at the root, top level of our workspace. I have a schematics folder, right? And what I want to do is basically open that up in the terminal and use our new schematics that we installed from Angular. And what they do is give us a schematics collection that allow us to create a blank schematic or a sample schematic that has like, I think 3 or 4 different schematic projects in there, or 3 or 4 schematic items. So this is what we get here from just running that command. And if we want to just list what's available, we can run schematics -- list schematics, and it's going to tell us that we have a blank and we have a schematic that we can run. So unfortunate naming here. So we're going to use the Angular schematics, and we're going to use this schematic to create a schematic collection of schematics using schematics, right? Crazy names. I don't know. I have never heard anything named like this before and such, but it's schematics creating schematics and such. So that's how it is. One thing we do when we create a schematic is we have to give it a name property. So we're going to call it getting started. And so that's our schematic. We're going to call it name getting started. I think that's all we need, and we're doing it in the right folder. So when we call this, basically what it's doing is going to create our schematic project in our schematics folder. And really what it is it's a npm package. So we have a package file, and we have all the things that a normal package would have. It's got a name and a version, and we call this .1. It's got a description, things like that. It's got build script, so we can build and test it and such. And it has dependencies here, and it looks like it's got some dependencies that are maybe for building it and also running tests. So it's kind of put all those grouped, all of those in the dependencies section here. But really what's important is this guy right here, is this schematics property, which is a unique property for schematics, which basically has a path value that points to a collection JSON file. And so this thing in and of itself, if you're using this package when it's deployed or when you share it with other users or use it within your own workspace, basically it's saying that this is a schematic and it would probably work differently. So if it doesn't have the schematics property, or they cannot find the collection JSON file by this path here, in this case it's located right here, then you're not going to be able to use it. So that is very important, right? So one of the first things we're going to do is we'll leave that as is for now, or should I remove this? Let me think. We're going to use this. We're going to build this and put it into a different location when we build it. And one reason for this is we don't want the output of a build to be side by side with actually our source code. I don't think that's a good practice. So what I'm going to do is when we build this, our package JSON file and our collection file will be in the same folder. They'll be siblings in the distribution, so we can remove source there. I think that's a good thing to do, and so we'll just do that. Save that. Let's take a look at some other things in this file here, or project. We have a tsconfig file, and basically it's the configuration for the TypeScript compiler. It's pretty strict. You might want to turn some of these to false, but they're there for a reason. So I think it's good practice. I haven't had any problems with any of those so far. So it's good when they compile and you need to make sure your code is clean and good. So that's good. One thing that we're going to do, though, is I think we would want to create an output directory. And the output directory will basically, instead of when we build this, putting all the output in the same folder as the source code, we're going to add an output directory, and we're going to target a distribution folder. So it's kind of like when we build our libs or our library projects or our app projects, it goes into a distribution folder. So we'll do the same. And instead of putting them, we'll put all of our schematics in a schematics folder. So if we modified that, we'll save those two things. So we got a change in our package file, because of the location of the collection, and then we have our collection file here. So let's talk a little bit about this collection file. It kind of looks scary with all this code comments, right? So I'm going to take those out, and we can talk about these things here. And what's going on here is it's just looking for a better path to this specific schema file. And I think that'll do it. There we go. Good. So it found a schema, and now that it finds a schema, it can apply that, and it says, hey, you're missing a factory property. What's going on? That's kind of good. What is a factory? So what's going on here is, let's kind of start at the top, and we'll collapse this file. So we got our schema, and this collection.json file is really a manifest for your schematic. So your schematic is a collection of one or more schematics. And in this case, if we look here on the left-hand side, we have 3 schematics for this collection, and they're all in a collection that's named schematics. So by default, that's the name that it's given, but you can give it any other name that you want. So this is really kind of a pointer to the collection name. And really it could, if you're doing being more pragmatic, maybe getting started would be the name of the collection, and then you'd have schematics that kind of belong to that. So this would be a good time to kind of think about organization of your schematics, just like anything else in programming and creating libraries and things that are shared and reused. You want to have good encapsulation, abstraction, single responsibility, separation of concerns. So you don't want to have one schematic kind of doing everything, kind of a junk drawer, hit a button, boil the ocean type schematic. You can decompose them into smaller ones, and then other schematics can call and use other schematics during the processing of them. So that way you can have a lot more reusability of your schematics, but that'll take a little more time in planning. But just to know that that's kind of what this file is for. It's for the organizational aspect of what your schematic collection name is going to be, and what those schematics are, and what they do, and how they work. So when we talk about these factories, really the factory is a function that just basically kicks off this specific schematic. So in this case here, like the my full schematic, it has a factory, and it's just pointing towards a folder. So what it's doing is using kind of the JavaScript node thing for like a barrel. So if we go into my full schematic, what we're going to see is an index file. So there it is. That's the entry point for that specific schematic. So close that up. There we go. Really, we just have all our import statements here. And then it's just basically a function, and it returns a rule, and it just does some stuff, right? So if we look at all these index files of each of these other schematics, that's all they're doing. So it's a default function. And if we look at this other one here, it's really kind of different. Where is it? This my schematic points to an index file, but it uses hash my schematic, and this allows us to basically name the function. So it doesn't have to be a default function. You can actually give it a specific name. So that might be interesting in terms of having a name that's more that defines what it's doing. So easier for developers to figure out and use. So that's cool. And that's why you can do it that way. So the collection file basically is a manifest. This is your collection name. I would suggest naming that to something different and better. And then these are your schematics that are part of this collection. So we got a factory, we got a description. There are other attributes that you can supply using go here, like aliases and things like that. So we'll look at that in the more details later, but I just want to get this thing running so that we can actually execute it and kick it off. So the next thing we want to do is basically build it. And if you remember in our package.json file, we did have a couple build scripts in here, but we don't want to build it in this folder. We want to use, when we're talking about workspaces, we're going to use the package.json file in the root of the workspace, right? So the root of the workspace, we already have a build file, okay? So what we're going to do now is basically get a set of build. Let me find them here so I don't have to. Oh, here we are. Okay, so I have a build script here, so I don't have to type all this out, right? So let's. Okay, what we have is a build script called build schematics, and what we're going to just do is do npm run, and we're just going to target our getting started build schematic here. And so really what that's doing in a nutshell is compiling using the TypeScript compiler. and then it's going to basically then call all these other build scripts, right? And these build scripts are going to do different things like copy the templates, the schema files, the package file, the collection file, the README file, all the things necessary to publish and use this schematic. And so one of the packages that we're going to use is called syncglob. So hopefully syncglob is installed. Let's just check because, all right, looks like it is, not enough argument. So it's there. So basically now that we have the schema here, we can now call npm run build schematics. And so this is kind of our entry point, line 8 there. This is going to kick off all the schematics in our workspace and build them. And if we wanted to build one individually, we could just call this guy here if we wanted. So this is just kind of simplification of our build scripts. So when we run that, what it's going to do is basically run that TSC, and it's going to copy all those files. And if all things are good, it's going to then put them in the distribution file folder. So it looks like it's copying the README. Looks like we're done there. So if we go to our close these up, if we go to our distribution folder, we have a schematics folder, and there we are. We're getting started. And if we open up my full schematic, we have everything in there. We have our JS files, our mapping files. We have our schema JSON file. We need that. We also have our template files, and these are our templates that by convention are put in a files folder that are used by these schematics to output folders and files when we execute a schematic. So if we look here in our getting started source, my full schematic, we have files and we have 2 templates. And if we go to our distribution, files, 2 templates. So we got everything we need here to actually now run this schematic. So the next thing we want to do is be able to execute and run that. So what we want to do is emulate the process of publishing to an npm and doing an npm install and getting that in our node modules folder and things like that. So we're not going to do that right now. So what we're going to do is we're going to use this command here. It's npm link. And basically what we're doing is just targeting the folder getting started in our distribution schematics location here. What this is going to do is it's going to link this something happened. npm link dist. Try that one more time. What do we got here? npm link cannot run. Why? Are we in the wrong folder? Yes, we are. So let's get out of here. All right. Now let's run npm link. So what it's doing is emulating that process of publishing and installing this package, and that's really what it is, just a package. So if this worked well, it's going to be in node modules, and it's probably called getting started is what we called it, right? And there it is. There's our package. So it's available as a node package now. We can actually call that using an ng generate. But one thing that I think is a good thing to do is in terms of our schematics is basically we used our scope. It didn't use scope by default. But in a workspace, if we are adding application projects or library projects, it'll add the scope there with them. So currently, schematic projects are not really kind of that paradigm, but maybe in the future they will be. So that'll be really cool. So we'll update the schematic scope there, and we can even do it here to save some time. Just go here and add the scope. Clear water, right? And I'm going to npm link again, and we're going to see the different location. And I like the organization of using scopes, especially in a development environment, because when we do that, we actually see them at the top of the list, so they're easier to find and navigate to. And there's our getting started schematic right there, right? So that's pretty cool. So then all we need to do to start using this thing is ng generate, or you can just do G for short, and it's going to be at Clearwater, right? Getting started, colon, and the name of our schematic. So let's run the my full schematic, right? And make this bigger so you can see. I'll run that. It's all going to work the first time, right? No, it isn't. I know it wasn't. And the reason why, it should tell us, could not find the module. Why not? Ng at Clearwater. Oh, getting started. My full schematic. Why did not find that? Okay, so could not find that module. I think that's what we had there. Let's just verify that. So node modules, Clearwater, getting started, my full schematic. And it's just a misspelling. Spelling counts, right? Always does. There's no spell checker in your CLI. So this is the error that I did expect. It said data path should have required property name. And this is interesting because if we go back to our collection JSON, it's not defined as required here, but in one of the schematics it probably is. And I think as a default it should be. So all we need to do then is just add the option. So the name option wasn't supplied. So let's say Clearwater rules, that's our name. Let's run it now. Yay. And so what we have, let's just close these things up here. We have new files. So we have a test file, test1. We have test2, and there's our input parameter that we put in. It used the template and it created this file. And then we have hola mundo and hello world. So we have these files created by the schematic. So a lot's going on there. So what happened? What did it do? And why did it do it that way when we called this specific schematic? So remember, we called the my full schematic, but it looks like we had other schematics run as well. So if we go to my full schematic, that's the one we targeted. And if we look at the what it's doing, it's using a chain, and it's going to execute lots of different things. So the first thing it does is uses a context, a schematic context, to write out my full schematic. And that's kind of what we got here in this first line. And we have the name and the index is 1. And it looks like that was passed in to the other schematic because it's calling my other schematic and it's passing in the options. So if we look at my other schematic, see what it's doing. It's logging my other schematic and passing in the options as well. So that's how we get these guys. Notice it's the options that were passed in from the first one, which is interesting because it just passed in true as an option. So actually, we didn't even set this option. It just passed it in, right? So let's go back. It called that my other schematic, and it created the OLA file, and then it also renamed it, and then it also called my schematic. So we can go to my schematic and see what it did there. Logged some stuff, passed in options, and that's how we got this options here, logged, and then it created the hello world file that we have, and then it returned the tree. The tree is basically the virtual file folder system with some other metadata tracking what is added, what's updated, because we saw one of those files being updated as well. And then outputting that and merging that to the existing virtual or physical file tree, which is the whole workspace. So that's the reason why these files were put in the root of the workspace. And if we look at like this test 2 here with the Clearwater rules, all we need to do is look at the template. So we didn't look at the templates yet. And all it is basically passing in that name option and outputting it right here. And that's how we get that file with that value in it. And then notice that we can actually create files, and it uses an underscore variable name underscore to build that. So that's how we get a test and a number 1 for that index file. This is test 1. So that's how that's created. So the options passed in basically can be used by the templates when they're passed into other templates and schematics, and then you get this this output here. So that's really cool. So what we've done is we've created a workspace environment. We've added a folder, and we've used the schematic to create a getting started. We could have just created a blank one and such, but this kind of gives us some interesting things to look at. And then the next thing we did is we updated the tsconfig to have an output directory. And then we updated package.json to point to the collection file in the location where it would be when we build it, which we basically configured in package.json with all of these little build scripts. So we just used npm run. We use the TypeScript compiler pointing towards the tsconfig, and then we use syncglob to basically move these files to the distribution folder, schematics, right? And then we use the command. Let's get it back up. Is it in my history here? The link, npm link command, and point it towards the getting started schematic in the distribution folder. And so that linked it, and that allowed us to basically use our schematic by calling ng generate our schematic, and then passing in the name option there. And that's pretty much it. So now we have the ability to put schematics in a workspace, build them, output them to a distribution, and then use them and apply them. So this is pretty straightforward, but you kind of get an idea of what's going on behind the scenes with schematics and what it's capable of doing. The next part in the next video, we're going to look at schematic options and how to configure strongly typed options, how to pass those in, how they're used, and such with the templates and things like that. And then the third part in this series is going to look at debugging schematics so that you can actually see how the code is working, and especially when you're working with custom schematics, that's one thing that we're going to need. So anyway, thanks for your time here, and then we'll look forward to those other presentations. Thanks.